So it's a day 7 of our 30-day streak challenge. So we have completed our 6 days of this challenge and it's a day 7 today. So let's go to the problem of the day section. The question is about row with max ones. It has been asked in Amazon, Microsoft. Hey there, coding enthusiasts. I'm Ampire and I'm thrilled to introduce you to my new daily quiz playlist on Python, Java and C++. Whether you are a beginner looking to hone your skills or a seasoned developer wanting to keep your knowledge sharp, these playlists are perfect for you. Just go to my channel, click on playlist section, and here you will find the treasure of tech knowledge sources. Each day I will be uploading new quiz questions to challenge you and help you master key concepts in Python, Java and C++. As you can see, the 3 playlists are available here from day 1, day 2, day 3, day 4 and so on. Subscribe to my channel and hit the bell icon so you never miss a question. Let's learn and grow together. Happy coding everyone. Let's solve the problem. Given a boolean 2D array consisting of only ones and zeros. Okay, 2 elements will be there, only zeros and ones, where each row is sorted. Okay, each row is sorted. Please make a note of this. Return the zero based index of the first row that has the most number of ones. If no such row exists, return -1. Okay, so the statements are pretty simple and clear. Let's see the time complexity. It's big of n plus m. Here n plus m. Here n means number of rows and m means number of columns. So we have to solve this under the time complexity of big of n plus m. It's not n cross m, it's n plus m. So we have to think something typical here. So how we are going to solve this problem? So they have, as I said, you to note a point that each row is sorted. So every row is sorted here. So we are going to use that trick to solve this problem. So basically, how I'm going to solve this problem is, initially let's keep something. Here we have to return the row with maximum ones. It means the row which is having maximum ones. If no row is having any single one, then we have to return -1. So the question is straightforward, right? So what we are going to do, as they have said already that every row is sorted. Every row is sorted. It means in ascending order. So what we are going to do, we are going to if we are going to consider a row, let's take the first row itself. We are going to consider a row and we are going to check the last value. If it is 0, it means all the values present in the array is 0. If it is 1, so after knowing that it is 1, we are going to traverse back. We are going to traverse back until we encounter 0. We are going back, and whenever we get 0, we'll just come out of that loop, and we'll make a note that till now whatever rows we have visited, this row is with the maximum ones. So as you can see here, there are 3 ones and we have visited only the single row. So this is a row with maximum ones. Okay, fine. Now moving forward to the second row. So here we are not going to start with the last value, that is 1. So what we are gonna do is, as the time complexity is big of n plus m, we will not visit from the last one. If we visit from the last one, it is like simple, easy. It's like similar to the big of n cross m itself. So to mark the difference, what we are going to do, last visited one, whatever the last visited one is there, we are going to make a note of this column number. We are going to make a note of this column number and we are going to store it somewhere. After storing that, whenever we visit the next row, we'll visit from the same column number. If it is 1, we'll move back. Otherwise, there is no, it doesn't make sense of by moving backside, right? So we'll come here and check what the value is. Is it 1 or 0? If it is 0, we'll just ignore this row and we'll go for the next row. Okay, now when we come to the next row, we'll see that it is 1. Okay, it is 1 here. So we'll just move back and we'll visit the next one. So we'll again move back. So there are no rows, so there are no columns here. So what does it mean? So this is a row with all values as 1. this is a row with all values 1, and there is, I mean, the maximum number of ones can be possible only, that is 4. That's the reason after checking to the first index, we can make sure that all the values in this array is 1, because as it is sorted array, so there will be no point of visiting other rows. There is no point of visiting, because this will be the row which has the maximum number of ones, and we will simply return the index of this row. What's that index of this row? 0, 1 and 2. Will return 2 at this spot itself. Otherwise, let's say we don't have 1 here, let's say it is 0 here, the value 1 is not there here, let's say 0. So whenever we are going to visit this row, we'll see that it's a 1. Okay, it will be fine. We'll move back and we'll check, is there any 1 here? No, it is not, I mean it is 0. So we'll just ignore this, because we have the similar in the first index, whatever we visited the first row, it is similar to that. So we'll move to the next row. So when we come to the next row, we'll see that there is a value 0 here. So definitely the values in front of this 0 will be definitely 0, and we don't care about the afterwards, because of the maximum one row is already noted here, that is 0th row. That is 0th row is already noted. And one more thing, here, as I said, let us consider it as 0. So we are having two similar rows. So in this scenario, we'll be returning the answer with which we have visited first. That's the reason they have mentioned here 0 based index of the first row that has the maximum number of ones. So first row will be this one. That's the reason we are returning in that way. Okay, and when it comes to the next example, so here also we are going to follow the same technique. We'll just make a point at we'll maintain a pointer in the end, and we'll check that it is a 0 or 1. So we know that it's a 0. We'll just move to the next row, and we see that it's a 1. So at this moment, we'll just move back till what time we are going to get 1. And when we just go behind this column, we came to know that this is a row with all ones, and we'll be returning this row itself. So let's code it, and let's try to analyze our code and try to understand and figure out what I actually want to convey you. So just moving here, first of all, let's say there will be scenarios, right, where all the values of the matrix are 0. There are no, I mean there is no single one. For in that scenario, we have to return -1, right? So because of that reason, what I'm going to do, I'm just going to make a note of resultant is equals to -1, right? And now I said that we are going to start from the right side, right? Because as it is sorted, we'll check from the end that whether it is 1 or 0, 1 or 0 from the end itself, right? So because of that reason, I need a pointer which is pointing in the end. For that reason, let's say int column pointer, right? Column pointer is equals to array of 0 dot length. So this will actually give us the last, I mean last index, length -1, right? So this is last index of the first row element. Okay, done. Now after this, we'll be visiting complete all the rows. Int I is equals to 0, I less than array dot length, and I plus plus, right? So after this, we'll just we'll do a thing, we'll create a pointer j, which will be storing the last whatever the last target point was there, that is column. And this column is for actually storing the previous row's last one position. For example, let's say we are on the row 2, we are on the second row here. Let's say we are on the second row, and I want to know that previous rows, what is the one's location. So one's location, last one's location, so it is here, that is 0, 1. So I'm going to store this column 1, 0th column, first column, right? So this first column in this variable col, so this column will be storing the 1 here. So after that, whenever I go to the next row, I'm not going to start from this end. I'm not going to start from this end. Actually, I'm going to start from here itself. That's the reason I'm storing int j is equals to column. And then after this, I'm just going to check while array of I and array of ij, if it is equals to 1, just simply visit the just decrement the j pointer, that is column pointer, and just move back, move back, move back until you get 1. So there will be scenarios where we are actually exceeding, we are going out of this index. Let's say j value is 5 4 3 2 1 0 and -1 -2. So in that scenario you will get error here, because there is nothing called like array of some value row and -1 index, right? So for that we have to mention a condition until j greater than or equal to 0. Until j greater than or equal to 0 we have to just decrement. And let's say, as we know here, the jth pointer, it will check it's a 1, it's a 1, it's a 1. After checking this is as 1, it will decrement the pointer j minus minus, and it will go for the backside. So it will be like exceeding, I mean it is proceeding to the index 0, so j value will become -1. In that scenario we come to know that this is a row with all ones, right? This is a row with all ones. This is a row with all ones. So in that scenario, if j equal to -1, in that scenario we'll just simply return this is a row with maximum ones, right? So simply at that instant we'll return I means the row number, right? So if our j pointer go beyond a 0 also, so it means a j pointer will become a negative, and we come to know that this is a row with maximum number of ones. So j is equals to -1, return I at that instant itself. After that, if j, let's say we came to this row, but we got the value as 0, so we'll not check for anything, right? As we come for this row 1, we are not going to check for this stuff, we are directly going to check for this stuff. It is, if it is equals to 0, then there is no point of like traversing back or front. So in that scenario it will not even decrement anything, it will just check this while condition, and the condition will become false and it will come out, and as usual j will be not equal to -1. In that scenario we'll just check whether our j pointer, whatever the j pointer is there, it has changed its location or not. If it is changed, it means there is a 1 here. If it is not changed, if it has not changed anything, it means it is similar 1. If it is, let's say if our j pointer changed some position, if our j pointer changed some position, it means there is a 1 there. So there is a 1 in this row, there is a 1 in this row when it compared to the previous row. So there is an extra 1, there is an extra 1 in this row. That's the reason our j pointer moved to the left side. It means it is a row with maximum number of ones when compared to the previous one. So we'll just make a note of that, and we'll store this column number, we'll store this column number in COL. And along with that we came to know that this is a row with maximum number of ones, right? So we'll just store it in our resultant variable, result is equals to I, and in the end we'll just return result. Let's compile and run. We got an error here, semicolon is missing. Fine, we'll compile and run again. Let's submit the code. So yes, all the test cases are getting passed. The solution is very easy, and it's very simple, guys. I just want you to go through the problem once, read the statement again, and just see the code, how beautifully we have coded it, how beautifully we planned it. So that's all for today. If you are having any more doubts, just comment it below, I will be definitely replying you. And that's all for the day. Thank you, bye bye.